Okay, my wonderful friends, our country is in trouble. The world is in trouble. We're spending money like water. This is the world's largest fusion project, is in big trouble, new documents reveal. Billions and billions of dollars over budget and decades behind schedule. And not even its leaders can say how much more money and time it will take. Certainly they say it will take another generation. It's been like, 30 years they've been trying to do this. Now, I believe I can show fission and fusion that can be carried around in a handheld device. This has turned into a disaster, and this is not somebody just silly off the street saying, "Oh, this is terrible." This is this is terrible. This guy's name is Charles Seife. It just came out today. It's a nightmare, absolute nightmare. This is never going to pay off, first of all, because they're doing it all wrong. They're trying to add energy and then take the energy back out. Well, you're not going to get much that way. Now, here's towards the end, he says, it's a mausoleum. It's not like a cathedral to anything. It's not a monument. It's a mausoleum, and it's never going to get any better. And this guy's, I think he's going to be good. I try to get a contact with him. He's a journalist. A journalist should write about what is seen to be possibly true or not. Just like this. They always write about, well, they're thinking this, or it could be this, or nobody really knows. To me, it's, we don't want to see your stuff. I don't know why. I'm hoping he'll be able to see it. And this is New York University. He's the author of the new book, Hawking and Selling of a Scientific Celebrity. And that's what it is. They're scientific celebrities now. I think I can get along with this guy. I think I get along with him real good. This is kind of funny. I'm just showing this quantum frustration. They have no clue what's going on. Leads to fundamental physics discovery, a new phase of matter. Well, I'm going to show you. I was just getting ready to show you it right now. This just came out 12 minutes ago. Popped up on my screen. And like I say, I don't know why they took it down. It's been up there since 2013. These are the two particles, are the ones I found. I just posted this 2 weeks ago. And this again is Don Lincoln's article. These are the two smallest particles they can find. And they are normally attached together. It's called a dirac. We split them apart. That's fission. They came back together. It's fusion. Okay, my friends, I don't see any reason to do this over again. This is all was done the other day, and this was only not even 2 weeks ago. This is the electron flood theory, and then the particles in space, which is always was called ether theory, and that's what we're scrubbing through. Now, this is what protons look like. When they explode atomic bombs, all the black part is in the center. The first thing comes the white, burns the house, then comes the black, knocks the house over. Those are the two particles that Don Lincoln was talking about. That article I was looking for, but I do show it here, so I don't know, they must have just removed it. Anyway, here goes. I'm sure they got heated up, but they didn't combust because they're not like combustible. All right, here goes. Just watch what happens. Just think about it. You can go back and play this and stop it here and there, but the first thing that happens, I will stop it. Boom, everything's just white, 100% white. And you can see the wires and everything starting to glow. You see them? And burn. You see them up here? The poles, anything combustible, the roof, all the shingles, everything. And even the smoke doesn't hardly blow back. It's just sort of blowing up. There's no impact from the white. It has no mass to speak of. And as I show you in Don's article, that's precisely what it says. It's basically a massless particle, and the other one is the fixed particle, never changes. You can see the metal things don't do anything, but here all your wires are combusting. Okay, I'm going to try to make this quick and easy. This is dipole electron flood theory. We're going to start talking about this, and got a couple little books going out. What's happening is this house will burn and then it will bang. The burning just goes up like this from the atomic bomb. The atomic bomb goes off, and behind the atomic bomb, you got the black in the center, the white comes first, then the black comes. Now watch. I'm going to go forward here. you're going to see a brilliant white glow, which is all of the atoms in the air are being excited. Boom! You see it? Every atom in the air. Now it's just burning up. It's just burning. Nothing's been moved. Not a single thing has moved. It's just everything combustible has combusted. Now watch what happens when the black particles come. There it goes.
No, they're going to come back.
Now watch everything turn around and come back. Watch. See it? It's
all right. The reason it's coming back is it's going back to fuse, back to the original stuff. It's got a cavity back there, basically a void. So it's fission of the white particles, then the black particles, then they turn around and come back to mix back together. Well, we got the exact same thing, basically, except it's all on one side or the other. Now, this is basically identical to an atomic bomb. Right over there, the atomic bomb went off. Only for us, it's a laser coming through the accelerator. The black particles are just pushing the white. Now, we have another version of this where just the white comes through and there is no black. This shows you that the black pushes the white. The black never grows. The white can get big. It can get tiny. And we can see these actually propagate in the air, creating the neutrinos into the photons, into this. And these gigantic fusion reactors are just a boondoggle, I'm telling you right now. And they should look at this, and I can't imagine why they wouldn't. All right, these are a lot of different, these are some experiments I did right here in my shop. And then there was other ones done by Rod Warren. He did the really good stuff. And we can see the particles accelerate. We can see them split. We can see them come back. Okay, we're going to have all new books about the new theory and so forth. But what's happening now is the bomb is going to go off. Everything that's facing the bomb, which will be here, is going to just burn and smoke, and then it'll knock it all down, because the first thing that hits is the white matter, then the black matter comes. The black matter has all the weight, just as it says in that article about what's the point. Now, here's what's going to happen. The first thing you'll see is a brilliant glow. All right, a brilliant glow, which means every particle in the air is popped. You see it? Now, all of the combustibles are burning, all of it, every single bit. This didn't burn, and the side didn't burn because it's not head on. Now the house goes because the black particles are coming. You see it, all that stuff is being forced. See it turn around, come back? That's because of fusion going out. Fusion is the white and then the black. They want to get back together, so they turn around and come back together to meet up. Fission and fusion right there in an atomic bomb. I think they understand fission and fusion from an atomic bomb. We did it with light. So this is basically an atomic bomb of light. It came out of here with a vengeance. The black is pushing the white. If the house was right here, the house would burn up and not move. And then the black hits it. That's when it goes. This was one that had both the black and the white coming through the venturi. We have other ones shot with just the white coming through the venturi. That's what we want if we were able to use it to get free energy. And I don't see why we shouldn't be able to do that. Hold on, I got a little diagram up here showing free energy somewhere. Here it is right here. You see this? Why can't we take this? This right here is this. All right, can you see that? Hold on. Hold the fort. Don't go anywhere. Take it easy. Sit down. Take your load off. Here's the laser. Pew, 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 pew. We have black and white particles tied together, which I haven't shown you yet, I don't think, but I will show you. They're tied together, and at the venturi, they can't get through. Only the black can't get through. The white can squirt like crazy. This one's got both of them coming through, but we have other ones right here. It separates it, but then the black comes back in this way. I'll show you that right now. But if we can get all of that white stuff, this is called electron showers. They claim this is many billions to trillions of electron volts, which is much more than what we input into here to start this reaction. And the reaction happens because the fields, which they're trying to do head on now, all they're trying to do is make field to field. And that's all we did.
But we did it sideways. We forced them in this way. And the black just slammed them like a brick wall. Bam, bam, bam. Just as you see it pushing here. We were going pulsing. Boom, 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 boom. So at the Venturi, which is all, it just squirted them through. Squirted those through and separated them at the same time. Fission and fusion. Here it comes. These are the particles. Zoom. Nothing more than an atomic bomb on the top of a desktop, a subatomic bomb. All right. Now, this is just some particles. Now, here's the particles. It's exactly what Don Lincoln is showing, as you'll see in a second. The black one is a muon neutrino, and the glowy white one, this is the same particles. The glowy white one is the electron neutrino. Here they are right there. There's a muon neutrino. A muon neutrino, the black one. Never changes. He calls it a fixed particle. And this one is the point particle, can get big and small. And this is from 2013. That's the article, just was taken down. So I point that out, that is the one that is the bowling ball, never changes, and that's the one that can get all right. Now you come down at the bottom and it says exactly what I am saying. And in summary, the extended particle is a fixed particle, the black one, never changes. It might have a fuzzy edge, which is the color. I agree with that. The point-like particles are mathematical abstractions with zero size. I can't agree with that because I can't think of anything that could have a field and has no size whatsoever. However, it does not seem to have weight. How it can make a field and have no weight, I do not know. But it pushes against anything else with a field. So we have the extended particle, fixed size, never changes, the black one. The other one is an abstraction with zero size, he says. But even zero-sized particles have an extended effect due to the effect of the field surrounding them. So if you didn't see, he's pointing out precisely the particles that we found. These are the same particles we found. So I think they should look at this, because what I have is something you could carry around in your hand. Just a small portable device. What they have done is spent trillions, literally over the course of these years, trillions of our money, and they have never gotten anything for it, nothing whatsoever. Now, if we could put these little lasers doing what I'm talking about like here, and harvest that energy, which is just the glowy one. That's all we want. We don't want the black ones. The black ones don't do anything for us. The black ones are the suckers. If we have the white ones, we put them in the battery, the black ones will suck it to it through motors, through anything, not generator. A generator makes electricity, but it will suck it through motors and all kinds of things. Okay, if you didn't get it, go back and look again, because if we could get something in a box like this you could carry around with electricity, make any voltage, any cycles, AC, DC, anything you want, that's just regulation. Once you get the electricity, once you get the electrons, which are these white particles, stuffed down into batteries, or you can just draw it right out of this thing, because this never stops. It's not like you make one big pulse and you get a bunch of electricity and then you got wait another week or something. These people are way off track. This, you squirt it down through what's called a photodiode. A diode means you can go one direction, you cannot come back. This is slapping the hell out of these white particles, and they're just floating around. They don't hardly do anything. You saw what they did. They just burnt up the house. So if you could just slam these suckers down in there, you're going to force them down into your battery stack. Once you have them in your battery stack, you're good to go. And you're not going to need cars with 2,000 or 3,000 pounds of batteries. That's insanity. If this thing is running, you should have plenty of electricity right here to run just about anything that I can think of. If they're right about electron showers having trillions, or at least many billions of electron volts, the increase in energy should be staggering. Not only that, these are so small that you should be able to put hundreds and hundreds and hundreds, maybe thousands inside of a little box like this. Carry it around, plug anything you want into it, make them watertight and all that stuff. We'll make it all designed new. I can't do this. I need somebody to do this. But I can show you, and I can talk about, I know a lot about this. It's not that I don't know anything about it. I just don't have the facilities or anything. You need transition metals here.
You need transition metal collectors. You could have them on a thin film roller sheet that every week or so it would roll a new set of thin film in, or a new set of thin film, new set of thin film. So because they're going to wear out. This is not going to, and it's just going to be like almost like the old reels of cinema film. You have one up here, one down here, and every so often it would click a whole new set of transition metals that would feed down into your batteries, because they're going to wear out. You bombard something with electrons like this, it's going to wear it out sooner or later. Now, the ones, well, let's forget about the solar panels that they have now, because they don't harvest hardly at all. And they're very, very expensive. They're heavy. You can't carry them around with you. If you carry them around with you, you're only going to get just enough to charge your phone. This should run a car. This, you should be able to run a car, heat your house, all that stuff with just one of these things. I would think, if you read what it says, and I think I got it here. Hold on. I think I put it in here. All right. This is the ultraviolet catastrophe. When you heat up stuff, it gives off electrons. That's what heat is electrons. You keep heating it up, heating it up, heating it up, it's going to keep giving more and more and more electrons. Well, at a certain point, there's no more electrons to give out. You give them out here, give them out here, and then it starts, no more red left, no more green left. The blue is the tightest, tight. Those go, and then you have the ultraviolet catastrophe, which means there's no more light particles to give off. All you got now is bangers, and the thing just drops right down to zero. So that's why, because you have no extra electrons left. I can explain anything you can come up with electron flood theory. And I'm not bragging. I'm just, like my old boss used to say, it ain't bragging if it's true, and it is true. Because I understand precisely how the atomic nucleus is constructed now. And there's only two particles, that red one and the black one, just as they showed at Fermilab, and they took that down because it sort of makes them look silly. We did everything we did for less than $500. That's a big difference between, I guess got to be trillions by now. Okay, this is extremely simple. This is the light from a pulsed red laser. It has to bang through all the particles in the air that have magnetic signatures, which every single particle does. Oxygen, hydrogen, nitrogen, all in the air. Now, boom, 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 boom. These are the pulses. Inside of each one of these pulses is a photon. That photon has a field surrounding it, huge. And it's got to get through all these particles. The field has to push that field out of the way. So that's why we see the glow. Anytime there's push and somebody else is shoving back, I call it push to shove, you end up with a glow. Now, what happened next? That thing here turned into this thing here as it approached our Venturi, which is a known accelerator. It's very, very well understood. But nobody knows about light being able to do this until we did it. Now, the light comes through here in pulsations. Now the particle itself is beginning to accelerate. You see that? That's just like a jet fighter breaking the speed barrier, speed of sound, and you see all this concussion. Now it's really starting to gain energy. You may not be able to see it, but it's starting to get glowier and glowier. And here you can absolutely see it. Glowy, 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 smash. Now, what happened right here? This is a Venturi which crushes the fields, and they get slapped by the fixed particles. They're just like a brick hitting them. And they squirt them through the other side. And then they reattach here. This is fission. This is fusion. This is electron showers. Can I prove that? I believe I can. That's what Fermilab and CERN say. They say the muon, which is the black particle, attaches to the electron neutrino. So those are the two neutrinos, muon and electron neutrino. The black one is this one here. And it just takes off on its own and goes wherever it goes. The white one turns into a shower. Absolutely. There it is. What happens here? And what happens around here? And what happens over here? And what happens over here? The black ones, they jump right back into the white ones, or the white ones jump right back into the black ones. I don't care how you look at it. That is fission here. You saw them attached together. There's no question, and I'll show them to you again, because I'll show you the neutrino values too. Here there is 100% zero blackness, and here they come right back together. They never change size. You see them here? They're the same size ones over here. And they must be everywhere. because these didn't jump over and get attached here. When we saw them come through, they were attached together. So there's got to be some other black ones that are laying around to reattach to the white ones. That's the only thing I can take out of that. All right, so you saw the wave coming through, you saw it accelerating, you saw it dividing, fission and fusion, and these are the particles that you're seeing. Out here, they're called the Majorna electron neutrinos, or Majorna neutrinos, whatever you want to call them. Well, they're diaracs and Majornas. The diarac is when you can really see the black and the white, when it's really concussing. These are when they're sort of floating through the air. You can see them, but they're not like when they are getting ready for their photon concussion here. This is a concussed neutrinos. This is unconcussed neutrinos. Can I show you neutrinos? Absolutely. These are neutrinos. Right there. That's a neutrino. That's a neutrino. They're all neutrinos. They're coming this way, but they have not gained enough energy to show up as a photon. This is a photon. So they come this way, and then they go sideways. And I can't tell you why this happens the way it happens, but I know they're stacking up on themselves, gaining mass. Mass is nothing more than an impact value. Back here, it's just sort of going, and now it's starting to really, and this field's pushing back at it. There's more mass being, and then really gets massive as crazy. And then they get really bright, and then they explode right here. Here's the explosion zone, and here's the explosion of the white particles right at the Venturi. Now, this is red, very weak compared to the green. Here's the green. Same particles, same neutrinos, same particles. This one's getting ready to spin. See the leading forward white? This is the same particle, but here it's got more energy. It's getting ready to spin. It's going to flip to the back, and then this one will come up in the front and start to absorb the energy, just like the red one I showed you before. All right. And the same thing happens here. This is the same particle. See the white up at the top is forward, and the white at the bottom now. It's flipped. And they do that. As they come forward, they gain energy. The white one gains energy. The black one does not. Oh, as a matter of fact, I can show you that even better. Hold on a second. Hold on. I either showed you or I will show you. These are the point particles that Don Lincoln talked about, point and fixed particles from Fermilab 10 years ago. And I tried to engage with him somewhere in that area, showing him that we found his particles, and I never got anywhere. But anyway, these are the particles. And the reason I say, look here. You see this leading one, how glowy it is compared to that one? That one there is getting diminished. This one's getting pumped up because of those red particles in front. You see them? You see these little red particles? They're banging into those fields. The field against field causes glow. It's just the nature of it. If you hit against a wall, it glows. If you hit against, because they all have fields. Everything there is has a field around it. Until you get down to just the dark matter, there's no field. And what that does is it sucks all the electrons. And this is another thing I tried to show Fermilab, is about what the Russians did. This goes back to 2015. There it is right here. This is what it does. It's exactly what happens. You expect this to happen with electron flood theory. They had no clue. They said they sent this back to Earth. This is in outer space in a vacuum chamber, charged particles, micron-sized, and they collect around the dark matter. Exactly what happens on Earth. Identical. We've never seen the dark matter because it's always completely surrounded. Now, this is this goes back to 2015, and this is when I try to contact Don at Fermilab. And I said, geez, there's some interesting stuff, and it didn't go too well, so that's what we got now. But I think it's time to take a look at this. 10 years, not quite, but in that area, I would think it's time to, especially with these failures they're talking about of these gigantic colliders, they were never going to work in the first place. And all that CERN, and I went to the University of Geneva in Switzerland online, and I showed them all this stuff. I said, you've got to focus, you got to use CMOS, we're doing all that. And guess what? About a year or two later, they shut down CERN
to put in focusing magnets and CMOS detectors. I'm not kidding you. I had talked to them about this. I said, can we engage? And they said, no, we'll follow you on Facebook. And I said, okay, what are you going to do? You can't force it. So, but they want to work with protons, thinking that a proton is different than this. They're trying to get to the smallest particles, which they have found. In that article, either I have shown you, or I will show you, these are the two smallest particles. And one of them is fixed. It never goes any different than that. It's a fixed, same size, one size fits all. And then you got the glowy part, which is dependent upon frequency and speed, basically, the speed of the spin, see it? See, the red one just weak. Through the same venturi, same time. The green one, it pushes itself through the disturbance of the red, just pushes it out of the way, keeps going, and then reconcusses out here. You see how much more powerful the green is than the red? The red is just dim looking. See, it's just nothing, almost. And there is no energy to the red, basically. With this green laser, no, not even the green. The green won't do it either, but the blue will. The blue, you can turn on CMOS LEDs. You take an LED that usually light comes out of it when you put energy in, you shine it in there and it will put energy out. If you got an LED laying around, just break it open, solder something on each side of it, put it on a meter, DC volts, and you're going to probably have to go into the 20 volt range because it gives you 2.5 volts. You take the blue and you put it right on that CMOS and there goes your electricity. And that's what we want to do with this. We want to put in CMOS to harvest the electricity. Because that's what it does. It sucks it right up. That's why these are so good, because they're done with CMOS. It eats electrons, and in the pixels, it turns them into an image. That's what CMOS is all about. It's fabulous. Okay, so we know this is a disaster. They're never going to even break even. They're trying to put energy in, thinking it's going to come back more. It's not going to. I don't think. Maybe it will, but I doubt it. Let's see what this is going to talk about here. This is what I just showed you electron showers. I don't know if you can disagree with that. I'm showing to you exactly what CERN and Fermilab say. These are electron showers. Where is it? Right here. Here's your electron showers, right there. Well, what do you get out of electron showers? Well, they say you get one hell of a lot of energy. This is physics, new physics, basically, electron showers. Physics of electron showers. And then they're doing something, they're trying to break big particles to get the electrons. You don't have to do that. You just use light. They're using proton-proton collisions and all kinds of stuff. And then a gigantic machine. It's insanity. To me, anyway, I'm sorry, I don't mean it that way, but they're not going to get anywhere. And I've been trying to push this on these people for years and years. But here's the deal. Once you get down to energy of neutrinos, you're up to 100 giga-electron volts to a few trillion electron volts. Because what you're doing is proton-proton collision. Then they have to make hadrons. Then it creates the neutrinos and antineutrinos and all the different flavors. And that's what you get is electrons and muon neutrinos. And that's where you get your energy. And that's what I did. And this gets very, very detailed. It's the same stuff we're doing. They're trying to do it, but they're just not doing it right. Here's your muons versus your electrons. You get back here and harvest out there, you got some serious energy. The muons are going to stay this way and just trail off. The electrons come through and pow. You see this? Electron showers, muon showers. Very interesting stuff. Anyway. Okay, I don't see any reason to go any further with this. I showed you all the different light experiments we did. This is the Fermilab, CERN sort of stuff. We found the same particles they found. But we know where they came from because we can watch them actually propagate and turn into their neutrino phases, then into their photon phase, and then break them apart, and then watch the fission and fusion as they come back together.